1. Going live.
Yeah, I'm searching the
And you're
stream.
live.
Nice. I'm searching the stream on my phone so I can look uh, for comments. Oh,
Okay, I'm here.
yeah. Just in case.
Okay.
Then we can start. And today's topic, that's also, what have you called it? Recreating Final Fantasy 15 Warp Strike in Unreal Engine. Sounds pretty
Yes.
cool.
Sounds cool. Let's see how it goes. We will just try to see how it goes. And of course, we will be focusing on the coding part. So we will be using blueprints. If it doesn't look too good, then we may polish it in the next stream where we may put particles or maybe create a Final Fantasy 15 map. So, but for this time, only the code. So for programmers, get ready. For artists that are learning to program like me, get more ready.
Yeah, hold on to your seats. And
Yeah.
let's show more or less what we're trying to achieve. Maybe you haven't played Final Fantasy 15. I haven't. I have seen a lot of gameplay, but uh, I haven't played
You don't miss much, but I think I enjoyed. I wouldn't say it's a bad game, but it's just not to the standard. But let's not touch that topic now. Too sensitive.
But well, the
But
warp, yeah, the warp strike happened at first. That's it. And
it can put some sound to check. Do you have sound in your
oh,
matching?
do you hear this?
I don't. Maybe we're using the computer sound, or it is.
Maybe for Discord it doesn't play. It should play on a stream.
Yeah, that makes sense. Yeah, because I'm hearing from Discord. Okay.
Yeah. I just check
Yeah,
on my phone.
I just test. It works. It works.
It works.
I'm saying because the sound is important to make the total feeling. We may add some sound later too. We are not entirely complete until we put all the details, but so for now it's just a rap strike, right? So let's try to analyze again before trying to create it.
So here we have like the first phase. Let me snip the screen, and we have some targeting here. I believe this is through a button, right? You have played. I haven't, so you.
Yes, you hold the button, and you will. I believe it's circle. I don't know what's the translation with the Xbox controller.
Yeah, and it will probably be like a little crosshair, maybe like this. And whenever you're near a target, then it probably changes like to this big one, so you know you can do something, like, right?
Yeah.
Yeah, and you were telling me that this also happened with objects, like if there is like a rock here, and please excuse my rock. If you target it, it has maybe the same or another crosshair.
Yeah, it's the same. It's the same.
Yeah,
As far
perfect.
as I remember, it's the same.
So we have that targeting phase, then we have the action, right? And here's a great detail they add that you were mentioning, like the camera gets a little delay.
Yeah.
Before impacting. Yeah, so whenever here Noctis throws the weapon collides, and then the phasing in and out happens, right?
Mm-hmm. Yeah. And there is a trail that follows him. It's a delayed strike,
Right.
basically.
And it sure seems that way because um, yeah, here it hits. You still have like Noctis here, even though it has already collided, but the camera will start moving like a little transition forward, and Noctis will not disappear yet. Like, let's see it in slow motion. So the uh, like the frame of the body is still there, but the camera is already moving, so it gives that feeling of delay, right? That makes it feel very good. I remember I have played like 5 minutes of it in an event.
It feels very good. It's very well made.
Yeah. And when the
I think
camera, oh yes,
I think it worth mentioning before that these kind of systems are extremely hard to make. We usually call it the three C's, stand as controller, character, and camera, and it's usually the relationship between the three of them that will create the total feeling. If you have the camera but you don't have the controller feeling right on the right time, you lose. If the character doesn't have the right animation but the controller and the camera is right, then you also lose. So this kind of combat system is actually pretty hard to polish. Maybe we will prototype it faster, but to polish it will be it will take some time.
yeah, and there are a lot of little details like in the hit. Here's an distortion effect here. The camera shakes around this part of the trail, of the attack.
Yeah.
And then there is a little animation of the remaining part of the action, right? Of returning to a position where you can attack again.
Yes. It also starts with anticipation.
Yeah,
With and it's pretty much a rule for any kind of mechanic in your game. You want to have some sort of anticipation thing to show that the player something's gonna happen. But we will just do it little by little.
so with what we have analyzed thus far, we can make a little flowchart, so we don't have to keep going back to a video every single time. It's gonna be useful to know, and I hope I don't have anything in the whiteboard. There it is. So whenever we
All right.
start, we need to be in a targeting like phase. So we start targeting. Then if I'm targeting something that can be targeted, then we can show the crosshair, right? So here is target.
Are you using a tablet?
Yes.
Damn, that's an upgrade. Programmer with a tablet.
It has helped me a lot with problems with the wrist, like having to exchange between using a mouse and a tablet really really relieves my fingers, to because moving the finger up and down, like it's not really a comfortable action, at least for me. Like it's probably easier for everyone to hold your fist closed than try to open your fingers as far as you can. So yeah, it's been a blessing having this tablet, and also yeah, you can you can draw a lot more easily. Well, my handwriting is is really not that good, but
that can help it, but
yeah, yeah.
still very nice.
So if the target is acceptable, and that's that's what why I'm reading it also. If it's acceptable, then we can do something here. Yes. And if it's not, then we keep waiting until the targeting is acceptable, right? Or until we leave this targeting phase, but we don't have to do like too much detail in this phase of making a flowchart. So let's go with the target is acceptable. What do we need to do? We need to change the crosshair. And we need to wait for the input. So input for the warp strike. Whoop. For the warp strike, pressed, and yeah, no amount of tabletness can help with my writing, but hopefully it's understandable. And
It
here,
is.
yeah, I just remember I can add text here. It's easier even, but yeah, I'll keep it in mind for the next for the next step. So if the input has been pressed, then we need to do the warp strike. The warp strike. So doing the warp strike like has its own steps because this is all that we need in order to like start programming right now, because yeah, you do the warp strike and then it's the end. But the warp strike has like we said sub steps, right? And those I do not remember, so let's watch it again. um, yeah, it starts by do we want to really throw the weapon? We can add it later also, so let's just not
Yeah,
sweat the
let's
details.
work on the intention first, and then we work on the details little by little.
All right. So
This
here,
is only visual.
yeah. I'll just add it so I don't forget it later. So we throw the weapon. Then, and I'm gonna add some. Okay, no, it's small. We throw the weapon. We make the character have this cool. This cool. How is this effect called? Like, it's not a fade. Well, this cool material, right? This facing out. So character faces out, then the camera starts moving. That's the stuff that we're gonna add. Camera goes to target, and then the character faces in. Well, character teleports target and character faces in. Here we have the camera shake. Camera shake plus every little single detail of the hit. VFX, sound effects, etc. So now we have a really clear idea of what we want to achieve before starting to program. This is really important because you may forget. There are a lot of steps here, so it's easy to forget. So now, let's start. Any questions, Mauricio?
Not for now. Just yeah, it's pretty clear. Just deal with the details little by little.
Yeah. So let's start. We need to start targeting somehow. So let's jump to Unreal 5. We do need a character. We're gonna do some shameless promotion here. We're gonna use a character we have done for the marketplace. Is this knight? Let me. So this knight, if we open it with Control E, and let me open this program so you can know what I'm typing. There is this Control E. It already have some movement inputs, gamepad inputs, mouse inputs, touch inputs, and an attack. Do you want to review this, or maybe it's?
I think we can a little bit.
Well, this is how it's looking right now. We have this attack. So every time you open a blueprint that you have not made, what you should look for first, and I'm sorry if you hear some construction background there, I can't do anything about that, but hopefully it keeps it interesting. So
keeps you awake.
Yeah. So in any new blueprint, you should always look to the viewport. The viewport is how the blueprint will look. Any blueprint is just a container of components. Here in the component tab, you will see every component that it's is making this blueprint, right? So we have a capsule component used for collisions in character, another component used to know the direction of the character, a skeletal mesh. This is the polygons, the mesh that has all the information on how the character looks, and also has the bone hierarchy of the character. So this can be animated, we can move the bones, and the bones influence the mesh. So that's how, if I move the arm bone, then also the mesh moves with it. Then what do we have? Also, we have this static mesh that represents this great sword is being attached because here in the components we have also like if you have used 3ds Max or Blender, you probably have seen this type of parenting. This type of parenting means that if I move this mesh, then whatever it's beneath it will move with it too. If I were to remove it by dropping it in the parent here, drop here to detach, then if I move the character, then the sword will stay in place. But that's not what I want. This static mesh greatsword also is being attached to the parent, to a socket a socket that we have made inside the skeleton of this character. And we also have a spring arm and a camera, which is pretty common to do for characters. We use a spring arm because this spring arm has the ability to do some collision testing. And this makes it easy if whenever our camera, and I'm gonna show it right here, I'm gonna add a cube. And this cube, I'm gonna put it there. If my camera starts overlapping, then it does that collision test. So we are not passing through walls or other characters. Whatever object says that it's blocking the camera channel, then it will do that collision test really easy and without having to do a lot of code. So yeah, those are the components that have something that we can see in the viewport. But because this is a character, we also have a character movement component. This is a component that has some properties here, like gravity scale, max acceleration. This comes with the engine. Epic created this component because it's really common for biped characters to walk around, to run. We have walking, jumping, falling, swimming. And this component dictates how the input we are passing it will be consumed. So having this in mind, we can now go to, let's check if there is something in the construction script. There isn't. And here we have the input code that supports all the movement and the attacks. Just to not get off topic really easily, like it always happens, these movement inputs will consume inputs. The way they do this is through the add movement input. This node will take in mind the inputs we are passing to this character, and this consumption will be seen by this character movement component, and this component will be the one that moves it forward. This is why we don't have any code here that sets the location. Like we don't do set actor location. This type of node, yeah.
That reminds me when I was trying blueprints. I was doing some platforms, and in order to move them, I add the component like interp movement. This is kind of similar, but this is like made for characters, right? Was
Yeah.
Kind of, or not really?
It's really similar. The difference is usually those interp components are acting on top of actors. In our case, this is a character, which is also a pawn, and we can have a class on how the gameplay framework works, but just to keep it really simple, and here the mighty tablet will help me. An actor will be anything that can be put into the level, right? So we have a cube here. This cube can be put into a level, and anything I wanted in the level will be an actor. So for example, this is an actor, this is an actor, this player start is also an actor, this reflection is also an actor, the lights also are actors. Whenever we need an actor that can support giving it inputs, if we want this, how do I select here? There it is. If we want this cube to work, this is not it. If we want it to work as a character, maybe your character is a little cube that moves around, and we have like an input. Let's call it a joystick. Then
Did you just need a perfect cube?
this whiteboard does stuff, and so here, whenever I want it to go forward and I want this cube to move forward with my input, this is a subclass of an actor that is called a pawn. So a pawn is an actor that can support inputs, and it will work for characters that are controlled by the player, and it will work for AI that can send commands to this cube, right? A subclass of the pawn is the character. And this character is the same as the pawn because it supports input from a player or for AI, but also adds the functionality of walking, movement, and everything else. So in pawns will be pretty common to see the set actor location whenever we consume the input. We will use also these nodes. If you see the target here is a pawn, but for a pawn you should create like a component that will do the action movement in order to be more clean. So this is why by using these inputs, and we should also we will talk about inputs for the targeting part, so there is no rush here. In the inputs we set up whenever we want an axis, what's the value of those of the axis, right? Because if the joystick is like tilted a little forward, it will not be a value of 1, maybe it could be 0.2. So the scale value is reduced, and we need a direction. In this case we are getting the rotation. This control rotation is the rotation of my player controller. My player controller in this case will be the where the camera is looking. So if I'm looking that way, if I press the forward button, it will go to where my camera is looking. And this is being done because we only need that yaw. The yaw value would be like it would be this value, like on the horizontal plane. Where are we looking? We really don't need to keep in mind like if we're looking up or down, if we're tilting our head like sideways. We don't need that because our movement is not of something that is flying. Because it's a character, we probably just need to move in the in two axes, and where we can jump also, right? But this character doesn't have jump. I just remember that we didn't add jump to this character. So that is why here in the code we are removing all the noise. We just need the yaw, and then with this direction we are getting the forward vector and the right vector. Whenever we have a vector or a direction, we can get it's like very easy to visualize in the forward, because if our direction is this way, our forward vector would be also in this way. But our right vector will be something that goes to the right, and this should make like a 90-degree angle. So it works because we want to go forward, then we use this vector. We want to go right, we use the perpendicular vector. And that's the gist of it. Here, this is for gamepad. The mouse just add a controller yaw input, because turning will be from left. Let me put this in new editor window. And turning it will be left from right, and looking up, looking down will be the pitch, because this is the pitch. We do not have roll. Roll usually doesn't feel that good in third-person characters. For some shooter, they do add some roll in the camera, like whenever the character is peeking and only moving the head. There you can add some roll to it. But for us, it really didn't matter. Also, we have an input action and attack. You can see that there are input actions and input axis, because the axis will return a value between minus, it really can be any value. Usually it's between -1 and 1, and this will fire every time, updating the value. Even if the value is 0, then it will fire. The input action, on the other hand, will only fire when it's pressed or when it's released, and is used for actions, like the name says. Like, if I want to attack, that's an action. If I want to jump, I won't probably need it for it to fire every time, right? So whenever I attack, I press a button for attack, and then what I'm doing here is, what am I doing here? I'm checking if the anim instance is implementing an interface, and then I'm sending an attack action. It's done this way, and interface is another whole topic we can sometime in the future check. But what I'm saying is that this class, that anim instance, is the, yeah.
I think I was mute. I just said before that the move forward and the move right made a lot of sense, since when you draw the arrows, I'd never understood that part. And I was also asking what is an interface, but you just said like it's just another whole topic.
Yeah, it's pretty easy because Unreal gives you like this code already. It's pretty easy to just assume it works by magic and never try to ask why. And yeah, that's why. And
Right.
like the basics of any interface, it's just a way to declare functionality without even implementing it. For example, if I open this file that is called BPI inputs, I can open it quickly by pressing Ctrl P. Just type in the name, inputs. We have function here, and this function does not have an, if we see the nodes, it doesn't have any. What this allows us to do is to declare the implementation of this function wherever we want. So in this case, we're asking the anim instance. The anim instance, if we press on the character mesh, the skeleton mesh, here we have the anim class, that is the blueprint character, the character blueprint.
Mm-hmm.
So this character blueprint is just a class, but whenever we press play, we are not using the class, we're using an instance of that class. So we get the anim instance. And let me open that character blueprint. I'm gonna search it. I have it right here, double click it. Here we have event pressed attack input, and it's called exactly the same. In order for us to use it, we need to implement, like declare that we will use this interface. We do that by going to the class settings, and here implemented interface, we can add any interface we want, in this case our inputs. And here in the inputs, we can see press attack input. Then in my blueprint character blueprint, I can right click it and it will be press attack input. We can call that function if we need to play it or call it. Well, but if we want to implement it, we can add the event. And now we have it here. If we don't remember how it's called, then here in interfaces, we have all the functions that interface is declaring. So we can right click it, implement the event, and we will have it again.
Great.
And well, this interface just asks if there is any montage playing, and we play the attack montage that, well, is just an animation attack with the trail. So let me close that. That's the basic setup of the character. We are using interface here just to spice it up, because this will mean that if you create another character blueprint, you don't need to cast it. Here we're not doing any types of cast, so we are keeping it clean. And by keeping it clean, if we open the size map, here we only have the skeletal. Oh, well, to explain a little bit about this. This is a map of every asset this blueprint is using. And if you don't want to use that shortcut, you can also click Asset, Size Map. And here we can see all the references to other objects it has. We have, without these assets, this blueprint couldn't exist. We are using a skeletal mesh, we are using a static mesh for the sword, and an animation blueprint, because we have defined it.
So basically never delete files in game development as a rule.
Especially if it's being referenced somewhere.
Which it should.
Yeah.
I mean, if it's not having a reference with anything, then why is it in the content browser anyway?
And the last part of the character is just enabling some physics. We just give them a bow name and add some physics to them. The sideward, so whenever we move, we have some collision, some physics in the armor. So now that we have covered our character, we can finally start with the implementation of our warp strike. So let's start with the targeting. We need to enter a targeting mode. That it can differ to the camera, like the behavior that the camera has actually, but we want to keep it simple. So first we need a button to start targeting. We need to add an input. So let's go to the settings, project settings. And here in engine, we have input. Because I only want it to start whenever I click something or whenever I press a key, we don't need an axis mapping. We just need an action mapping. Here I'm gonna call it targeting. I could call it start targeting, whatever you like, and I will bind it to the right mouse button. Having done this, because this is a character which is a pound, we can see the input easily by just typing targeting. There it is. And now we have two types of execution inputs. We have the press, the release. If we press, we want to start targeting. And if we release, we want to stop targeting. You could handle this in a lot of ways. The cleanest of the ways is just making functions or events separate. So for example, if I want to start targeting mode, then I should create an event called start targeting mode. And I added a G here. And then also an event to end it. And now we can call it. On the press we will start, and on the end we will end. On the release we will end targeting mode. This makes it really easy for someone else to open the code and see, oh, how is the targeting being done? We have this input, and this input calls this event. We should also comment attack input target.
And the event is like the function where we will put our logic.
That's right. Our event, calling an event will run automatically all code that is being associated with this event. So if we have here like a debug string, like let's keep it like hello, and in the end we have bye. Then whenever we play, if I start right clicking, we will see hello, and whenever I stop right clicking, we will see bye. So we know the inputs are working. And
okay, so we finish our live stream.
Yeah, it's done.
Works with print screens. This is, I remember I used to put that in the university when I was in C++ classes many years ago, so I just don't remember. But I was so bad at it, and whenever there was a code and I need to comment on it, I just put a print screen or something like that, and it was like, it just said, this is where my code will be if I knew how to write it. But I mean, it works. I just need to know how to write it, but it goes here.
I see a question that could be really interesting to have as a highlight. They say, how did you import the character model in the Unreal Engine 5? So to import anything to Unreal Engine 5 from the marketplace, there are two ways. You can force it, and it really doesn't like it that much, but let's show it. Here in the launcher, you go to your library, and I have a lot of stuff here. Yeah, and let me find something that I have used already, so I don't need to download it again. Advanced locomotion system. No, that creates a project. It doesn't add a dynamic locomotion create project. No, I need it. Add to project. Environment set. I won't add it because it will take a lot of time, but you can add to project. And here you need to click on show all projects. This project is called demo blink / then you find it like demo blink. And it doesn't show because maybe I just created it, but here I have some other projects that are in 5 early access. It will show that the assets are not compatible, like lies. it does work, you just need to select another version, and now you can add it to a project. You can do it like this, or a easier way to do it that it's not that clean. Like,
Basically, they're talking about the marketplace file version rather than the engine version. That is, there's simply not any version from the marketplace asset in Unreal Engine 5 right now, right?
yeah, yeah, and yeah, you can't add also like support. There isn't our Unreal gives us a checkbox, like a checklist where you can specify like we support this version, and etc. Yeah, it doesn't give us that um, for Unreal 5. And the other way, the other way to import something without going through all the hassle of the launcher is you just need to find. Let's say we downloaded this environment set. All these files are being stored on your PC before being copied to your project. You can find it on wherever you installed the launcher. Usually it's in program files x86 Epic Games launcher, and you will have a vault cache. Here are all the assets you have downloaded. Here's my environment. I believe this is, yeah, environment, data, content, environment set. This is it. Then the names will not be really that friendly, but you can guess like the the content, right? So we have this environment set, and here we only have the content folder. That's exactly what we need, because here are the environment, here are the maps. So whenever we find the content folder, we can copy what's inside, like just copy. And you just need to go to your project here. You can find it easy, like this. Click on any file, show in Explorer, it will open. Then you just need to go back, demo blink slash, and inside the content folder, and this part is important, everything related to the content should be inside the content folder. We can paste it here. And if I paste it, and I'm gonna cancel it, if I paste it, then it will start showing here. You can see it already created, it already updated. I cancel the copy, but you can import stuff like this without Unreal telling you that no, it's not compatible. Yeah, you will really know if something is incompatible whenever you try to open it, and maybe you can crash the engine, or it will look weird, or maybe some materials that do not render properly, or some blueprint code is not is giving you trouble, like showing you some errors. For example, let me make a division by 0. Divide. This shouldn't crash my my computer.
Don't do it.
Integer. Literal int. This is just so I don't need to create a variable. So let's divide 0 by 0 and put the result on the print string. If I compile it, oh, it will pop up during gameplay. I really do not want that, so it's easier if I do this. Set max fly speed, and I will remove the target. It will not find the variable, and it will give an error. This is like what could happen if you import a blueprint that is really not supported by Unreal 5. It will give you this little icon that it does not compile, but it will give a hint on how to fix it, right? It will be created with C++ Blueprint of both C++ and Blueprint. If you're asking about importing things to Unreal 5, I'm talking about only blueprints. Code like plugins, those the creator needs to recompile and give you a special zip that is compiled for this version. Those really do not have support.
Yeah, he's just referring if we will be creating this in C++ or
Oh,
blueprints. But for the future, maybe we can do C++. I already told him that we are blueprints only for now.
yeah,
If
because
there is enough interest, we can do the C++.
yeah, we would need an slot with more time because compiling C++ can take a little bit. I should really upgrade my computer in order to support those type of live streams. But yeah.
He'll be mentally prepared to watch the C++ class.
So, I got lost, I got sidetracked, but it was an interesting question that we could resolve easily. Let's open again our flowchart, and we had the targeting. What do we need for the target? A little crosshair would be nice. Let's create it fast, and I won't go too much in depth on how to create UI. Let me delete this before anything weird happens. Yeah, let's leave it like that. New folder. I'm gonna call it exactly as my demo, as my project. So I know everything else has been imported from somewhere else. Here I will create a folder called UI, and I just need to create a user interface widget blueprint. The widgets are our main source of UI here in Unreal. Widget blueprint crosshair. And if we want this crosshair to be exactly on top, in the center, we can add an image. And I want to be importing an image. Maybe you can spice it up in the next video where we try to make it look really cool. We just need to set the anchor to a middle, and here position 0, y 0, alignment. We see that the alignment is on the top left. I want it on the center, so 0.5, 0.5. And this size should be a little more small.
Like square.
And yeah, also square. So 2020 should be fine for now. Then you can increase the size and give it a little more a better feeling. We have created this, and now we need to use it. We need to enable it whenever we are in that targeting mode. Easiest way to do it. Oh yeah.
I just watched the video. Whenever the target, you see the target is bigger, and then it gets smaller. Well, it's not smaller. It's just it has an animation. Is it something that we should care about now?
That it goes bigger.
Because it's like a sign to confirm that you have successfully triggered the rapid strike.
Right.
Even if it's not pretty, like if we change the size, like from big square to small, I think it will add a lot of value.
Yeah, we can do that. That's
just
actually
just to make sure if.
But whenever you're walking around, you do not have the target, right? like the square, it should not
It's
show.
automatically. Uh,
This is pure combat.
it only shows when you put the camera there, just like you did with the anime girl, where it's like automatically target, something like that.
All right, all right. Okay, that sounds good. So let's create a little animation for it. This square, I have selected it. I want it to get bigger. Um, you could change the size, but usually for this type of things, if you are using like um, textures with different sizes, maybe you could just scale it up or down. In my case, maybe let's see. Let's first create an animation. We can create a UI animation here in animations plus animation. Um, grow crosshair. The thing with animation is that if we can do a lot of changes, but it will not save if we do not select the animation where we want to save it. So let's select the animation. Let's add a track. To add easily a track, we can, I'm going to scale it here in transform, scale, and let me add a track. I can add, let's change the name image to image crosshair. So now with this selected, add track, image crosshair, great. We need the render transform, so let's track it. Render opacity, no, transform, here it is. We want the rotate, no, the scale. And in 0, I want it to be normal. And it's a good idea to always work between the ranges of 1 and 0. So then we can alter the play rate if we wanted to go faster or we wanted to go slower. So I will press this button that set the playbacks to end to the current position, that is this one. Let's click it. And now in my scale, I'm gonna press add new key. And in this key, I will change it to maybe twice the size. So there it is. And I'm gonna add the key again so I can save the value. And now my animation is like this. I could play it. You will see that it's really slow right now, but we won't care too much about it because we can edit that play rate animation later here in the graph. So also, if you haven't seen this type of editor before, the UI editor, the UI editor has, like the blueprint, a lot of components that are called widgets, and also a graph where we can add some stuff. So
Before you continue, I think
yeah,
it was from big to small.
from big to small.
Yep, it's like you press something, it's like squeezes the size.
Oh, I was thinking that you start the targeting and you look at something that you can target and it gets bigger, like this.
Let's see.
Oh, it's big from big to small. Yeah, you're right.
I mean, of course, it's a more polished animation, but uh,
Yeah.
from big to small, it feels right for the brain. That is like you press something.
Well,
I'm not sure. I mean, it's just a small detail, but I don't,
let me first up the
because
size.
we will need to change it later to actual animation.
Yeah, and we don't have to change anything really. whenever we play this animation here in the graph, you will have here the animations grow crosshair, and we can play it
in reverse.
and yeah, we just play it in reverse and it will work.
Cool.
Here is the play speed, so we can make it faster, we can make it slower if we need. So we
And
really
this is where in game development you find things like, who made this? Why is this in the reverse?
but
And you start trying to find the logic, like, why? It's like there's no why. It just fucked up.
yeah, it's a quick fix, so you don't need to edit this because there will be animations that are a lot complex and they use a lot of the curve editor. So for the scale, right now it's a simple curve, but whenever we want more interesting stuff, if we want a little bounce at the end, we can add it like this. And whenever we play, oh, I just moved my. Let me play it again. Yeah, we can see that there is another type of little animation, but it gets complex and complex whenever you use more than just the normal tangents. But in our case, it's pretty simple, so let's fix it like right away. I really do not want any problems later in the game. So let's change it to 1. I mean, the fix I gave, like reversing it, is a really good one whenever we are we have advanced a lot, we have a lot of progress on this, and we really don't want to fix anything because it already works, but because we're in the starting phases, I'm gonna call it here focus. Yeah, there it is. And if it's too large, then you could always change the size, the max size of it, maybe to 30. And everything, and the animation, because it's only touching on the scale, then it will work well. So now let's use the crosshair. We need to create it whenever we are start targeting. I'm gonna do it the quick and dirty way, and then I'm gonna show how it should be done in a production project, right? So we need to create a widget. We can right click it, create widget. We need the class of the widget. It's been called crosshair. Here it is. I'm gonna remove that print string. And here in the crosshair, if I want it to show up, then I can add it to the viewport. Here I need to remove it from the viewport, but I do not have a way to access it right now. I need to store a reference to this created object. So that's exactly what I will create. Here in the return value, I can right click it and promote a variable. This will be a crosshair UI references. And this reference will be populated whenever we start targeting this. We enter this targeting mode, right? Now we can use this reference. So whenever we end the targeting mode, then we can remove it. Now let's see if it works. I'm gonna press play. I'm gonna press right click, and there it is. There's the target. That maybe is not in the location that we want. Maybe we want it a little more on top. We can tweak it. Maybe here. And now this position, and I'm moving the anchor and not only the, the image, because I want it to scale well whenever. Right now here is in 720p, but if we wanted more resolution, then we want it to still be in relation with everything else. So that's why I'm moving the anchor also, not just the image.
That's a really good template background you have here. You need to activate anything, check it, or just drag.
This one? No, just drag. It
Yeah,
gives you
yeah,
the
well, since I use the widgets. I'm not sure if it was always like this.
yeah. It's from Unreal
Oh,
4.
that's great.
Let me return it to my 720p, living in the past, or with a machine that doesn't support too much. So let's check it again. I press Alt P just to play the game quicker. Right click, and now we have yeah, it can work. It will work just fine. So now,
Cool.
and maybe it is too small. Let me up its size. What will happen, and let's see it being play side by side with the blueprints. Here I will select the debug object that I want to see the execution. So I will press play. Now this character has been created. Now I can select that blueprint knight. Whenever I right click, the widget is being created, and whenever I release it, then it's being removed. The thing about this setup is that I'm creating the widget a lot of times, more times that I should really need to do. Because removing the parent, remove from parent, do not delete the object. Oh, I'm getting a call. Let me check real fast. It was a spam caller. I thought I was waiting a package, so that's what I needed to make a little pause there. Okay.
At least he speaks the same language. Whenever they call me, it's like, I hope you're the package, because I cannot get what you say.
So, like I was saying, this remove from parent does not delete this object. And where you want to create this widget blueprint really depends on your game. It's usually created on a class called HUD that we can create really easily by here in the content drawer, like right click, blueprint class, all classes, HUD, and here it is. But that would mean we would need to set up a player controller and set up a game mode, and we want this like not too professional. So the way we will fix this is check if this reference has been set. If this has been set, then this already has been created and we do not need to create it again. So I will add an if. The crosshair, I'm gonna get a reference. If you don't want to drop it on the graph and choose between get or set, you can drag it with control and it's a get, or you can drag it with an alt pressed and it's a set. And here I will ask if it's valid. And if it's valid, I do not want to create this, right? If this is valid, if it's true, then this should not execute, and if it's false, it should be like this. Just as a quick tip, you should always try to use positive logic. So you're using most, the result should be true, because it's easier to understand. Because yeah, here we are returning a false. If this condition gets too complex and you start negating the results, then you will have like an additional operation at the end. So yeah, remember that result that I gave you here? Yeah, now negate it because I want it just to be false. So in order for this to be true and use positive logic, then we just need to ask if this is not valid, then I should create this. So just add a not here. So it can be read like this. If the crosshair is not valid, then create it. And I will need to move this add to viewport. You can make it like this, but this is not really visually pleasing. So the way I will do it is just use a node for the manipulation of the execution flow. This one is called sequence. The sequence will execute whatever is on top first and whatever is on bottom second, and you can add a lot of pins here. So here I want to always add to viewport and with this reference like this. I don't want to use the same variable because I will depend on this pin like looking real. I don't know. It just depends on your taste, and I do not like it. So it's independent from each other. So this way, first we check if the crosshair reference has been set up. If it hasn't, if it's not valid, then we create it and we set it up, and then we add the viewport. So this way we're not creating a lot of UI that are not being used. When you right click, you see that the top part executed. Then we do it again, and we do not need to create it every time. You can see our HUD, our target is working just fine. Now we need to start. We have this targeting mode. We need to determine if the next step is the target is acceptable. And if the target is acceptable, then we can play the animation that we created here in the crosshair. So this will be done through a trace. The trace can be a line trace, a capsule trace, whatever you need. Usually for a targeting system is a line trace. It doesn't consume a lot of resources. So let's do it. And the thing about this trace is that we need to check a lot of times. Like we don't need to check it only when we right click the first time, but whenever this targeting mode is active. The usual way to do this would be through the event called tick. This tick will execute every frame. So if I put, I don't know, a print string hello, whenever I press play, it will print hello, 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 hello. What I need to do is know if I'm in this targeting mode. To know this, I need to store it into a variable. Let's call it is targeting. Let's keep it consistent. Is in targeting mode. And I just need a variable for if it is in targeting mode or if it isn't. So a boolean is perfect. It will store a value that is false or true. So here I can add another pin set up a start targeting mode. Yep. Whenever we have the UI, you are in targeting mode. And if we end it, we remove the UI and then we remove the targeting mode. Now with this variable in the tick, I can ask, are we in targeting mode? And if we are, if this is true, then we should start tracing. No? Line trace. So now we are starting a line trace, at least by name. To do the actual line trace, we need to use a node called line trace. And there are a lot of line traces, or well, traces in general. We have a sphere trace, multisphere, capsules, box. We just need a line trace. And here we have 3 flavors. We just need by channel, because the channel will be by default visibility channel and a camera channel. The camera channel was what I mentioned when we were talking about the spring arm. This cube blocks the camera channel, and that's why we have this collision whenever we activate the collision tests on the spring arm, on the spring arm component here. Like this one, do collision test, probe channel, camera. We would need a visibility usually, so let's do it. Visibility channel, we need a start point and an end point. Easiest way to do it would be using the location of the camera and tracing from there. Let's see if it works. Get camera. We need the actor location. Well, the word location, because it's a component. This is not an actor, it's a component, an actor component. We get the word location, that will be the start. And the end, I need, this is easier shown with the whiteboard. So we have this camera that is looking this way, and it created a trapezoid. Yeah, I want my ugly cube. This camera is looking this way. We have the start point. We have the start point. We want an end point. It will probably be here. So I need the direction the camera is looking, so I can add an specified type, an unspecified type of unit. So I can have 2 points where my trace can exist. And I do not want it to be like X positive. I just need to see if it's where is it looking, because if my camera rotates, then this direction changes. It will not be X positive, it will be X and Y. Oh, so what we need to do now is find this vector. This is called the forward vector. We have already used it. So every component and every actor has it. Camera, get forward vector. We have this starting point. We need to add it, this X amount of units. We will use the add. If I used the X value, I don't know, if 3,300, then it will only work on this axis, and we can see it clearly if I debug it for duration. Oh, this is in the tick for 1 frame, is alright. you can see that the X, it only worked that way. So that's why, in order for us to not calculate anything, we can just multiply this forward vector. And I don't need another vector, I just need... it now works like this, I believe. Multiply, I need to create a variable.
It's like the distance, the maximum distance from the target to work, right?
That's exactly it. And this target distance will be 500. We can use it.
So this is new in Unreal 5.
Yeah, this part is new in Unreal 5. Otherwise, we will need to
Convert.
Yeah, I don't know if it's called convert to float. Yeah, we will need to do something like this. This is how it's done in Unreal 4.
Right.
Now,
Nice.
Unreal gets smarter and just convert it.
Pretty cool.
So doing this, now we should have something working here. And it's colliding with the actor. And it's not working properly because the camera is looking at the actor. So maybe that direction will not work. Target trace distance. Gonna use this. Yeah, it's still colliding with a character. But just to finish the explanation, what we did is this vector, this direction vector, we multiply it by the units. So it got bigger. But now we need to find an appropriate start location and end location. We want to use this crosshair. Then it should be good to just find that location on the screen. I believe there was some notes for a screen location. A screen to local. Translate a screen position in pixels into local space of a widget with the given geometry. Yeah, that won't work really.
In my mind, it showed pretty accurate. Like if I know what it means.
I will add some actors to ignore here. So I'm gonna put make, and I'm gonna add itself because it should be being ignored, but by some reason it's not. Unless we could also fake it like really easy by creating here a component. A scene component and then targeting that, but that won't work really well with the camera. Maybe it will. Let's see. I'm gonna add it to the spring arm so it gets the movement. And this scene, as a debug, I will add a little cube. Now we see that the scene is here. And I want to change the location of this scene to be on front. This cube, I will reduce the scale because I just want to use it as a debug. tool. And then here I just need to remove the collisions so it doesn't becomes a bother. Play. And I don't see my... Where's my cube, man?
I'm gonna give you a neighbor.
If you don't find something, you can also... there it is. I use the... well, it really depends on the keyboard, but you can open this debug window with the apostrophe. And if you press tab, then you can also see all the components. There is my cube. So it was working. I just couldn't see it because it depends on the camera. There it is. No, I'm not liking this approach one bit. So what could we do then? Maybe I could get this position on the screen and then trace it forward. Let's see if we can do that. This image. Let's get it. And ask it the location. Visual lower, no. Word location, no.
Probably position. This is 2D. Nope.
It was called word. Project word location to widget position. Gets the projector word to a screen position. Then convert this in a widget position. Yeah, this we want the opposite of this. This can work. Convert mouse location to word space. Because our mouse is targeting, it's technically targeting this. So let's try that. Let's actually try that. In my night, let's remove the context sensitivity. Mouse, get mouse position. World. Oh, I lost the name. There it is. Get mouse location to world space. We need a player controller. This is a character. We can get the player controller easily. Get controller. And this is just a controller. We need a player controller. We can cast it to the player controller. You can also do the get player controller and it will ask an index and this will work. But just in case you want to develop a multiplayer game, then we can do it like this. So we don't need to bother a lot with the index of the players. Per controller, we have this world location and the world direction. We will replace this world location with this, and this forward vector like this. I'm placing control and then dragging the pin, and let's see what that does for us. Yeah, it's looking a lot better. I don't know why it's what happens if I add more distance. Maybe it's going in an opposite direction. It sure seems to.
Try the negative.
Yep. We just need to multiply it. And I do not need this. Make literal load 1. And this is the direction I need. Nope. And let me just remove this branch, just so we always have that trace. And that's not it. Then the direction was fine. And let me remove it. Oh, so it was working. And here is touching the floor, and here is touching the cube. It was working. It just didn't seem to. But it's not aligning with that with that
Oh,
crosshair. Hmm. What we can do then is I'm gonna use the rotation. This direction of the mouse is like what I was needing. And for the world location, I'm gonna use the camera. But we can leave it like this for now. Then we can tweak it for it to work on the real crosshair. Let's just get the basics done, and then we can start polishing. And we want the UI to change whenever we target something. So the easiest way to do this, well, the cleanest way to do this will be through, and let me clean some of this code, because even
I mean,
though,
I think we never changed the widget position after the trace, right? I mean, we are getting the trace, but we're not doing anything after the trace.
yeah, let me check the source material. They do it. Yeah. Oh, and it moves with the car. Oh, okay. So for this type of effect, then a 3D widget would be better than just this.
Definitely. Like a plane.
Yep.
Mm.
We can create a 3D widget for the crosshair. Like, let's go to the content drawer. Here in UI, blueprint class, and we can create a um, oh, I forgot the name. Widget. It's just called widget. I could add it here. Yeah, probably it's a good idea. Adding a widget like this will be a 3D component. If I move it and I select a class, in my case my crosshair.
Oh, it creates the plane
Yes,
for you.
there it is.
Amazing.
But this will require a little restructuring of my crosshair, because I really do not need that much space for it. Here we have 1500 by 1500. Let's use that value. I can custom it. And now this really should be in the center again. Let's reset the position. We still have our animation. Let me close this and let me close the interface. And now let me remove this cube. Let me move this scene widget. We should see the widget always. And let's see if I wanted to trace it there. That I'm not really digging the location or anything. So let me go back to how this was being done. Camera, world location, start. Here it is. And the direction I also want it from the camera. Oop. Get forward. Vector. Camera. Get forward. Let me check again the context sensitive so it's easier. Get forward vector. Now we have it like we did before. We can tweak this later. No worries. And let's connect that back. Let me remove this code just for this little bit.
Usually tweak this later until you ship the game.
So now it's a little easier to tweak the value. I don't need to create this widget like we did it before, because we are using a 3D version of it. And just let me change the color and opacity to something a little bit gray so it's easier to identify. Here I won't need this part of the code. I don't need to remove it also. And as you see, it's really easy to iterate in blueprints.
Yep.
So now whenever we target something, in this case, should be fine, like this. Just let me add here in the world location some units. Plus, let's multiply. Let me add it some units to the C value. That's a lot better. That's definitely a lot better. And maybe the start point can be normal and the other one can be a little. No. Let's add it to both. Oh no, I crashed.
Oh. Did you save?
Yeah, I should have. I was saving a lot.
Okay.
I just pressed Ctrl C. My bad.
So if you press Ctrl C, well, debugging this thing, it will crash.
Not necessarily. Let's use the game mode of the night so I can. Yeah, at least the widget color is different. Let's place the actor again. And oh, that's a box trigger. We need some cues. Let's open the character. It's called Night. Blueprint Night. I remove this. I remove this also. The widget is not added. No worries. We can add it like we did. Let me check the crosshair if I managed to change the size. Yes, I did. And now I was messing around with this get location. I wanted to add it some value 50 like this, like that. Forward vector, visibility 1 frame. Save it, compile, play. Yeah, it was lacking a little more distance. And now we have it. Because even looking that way is giving it what we want, exactly what we want. So
How
now
do you get out of the possess mode?
Of the what?
Of possessing the player.
Oh,
You're possessing the player and then you depossess and can fly around the world.
yeah. That's with the apostrophe key. Apostrophe. We have this
okay.
debug that is really useful when you're doing AI. You have nav mesh, AI behavior tree, etc. If you press tab, you can fly around like you have unpossessed.
Okay.
Yeah. The other way here is selecting the viewport, pressing Shift F1, and just unpossess it here.
That's what I usually use. But you don't have that option when you play from the blueprint.
Yeah, from new editor, you do not have that option. You just need to use this one. Yes. I really do not like to just minimizing, coming back here, testing it. I just want to play from here.
It will be surprising, but me neither. Now that I can have played with blueprints a little bit, I use the small window a lot.
Yeah. It's really useful. So now we have something that is colliding with the world. We need to show the widget when that happened. And here I will add the widget class. My crosshair should be right here. I've moved it. And I could get away with making it two-sided. I could change the material to make it two-sided, but I don't want to worry too much about it. If I need the widget to appear on the thing it's being collided on, then what we would need to do will be to get where am I colliding and then moving it around there. So here, the line trace, we just need this widget, set work location, and this trace, we just need the out hit. Well, we need to know if it collided with something, but I'm just gonna break this result and get the location. I could get the impact point, but this is usually done when this trace is another thing apart from the line trace. So the location is fine. I'm gonna press play, and here is colliding with this part. Oh, and it's following me around. That's why this should not happen. So what this reveals is that this cannot be a component inside this blueprint because it will move around whenever the base component moves. So I just need to create it somewhere. This is a widget component. Here in my content drawer, I can create a widget component. I'll create a blueprint. I can find a widget component to create my own component, but I will probably need to put it on the on the level. So actor, and this will be my blueprint crosshair. Add a crosshair the same way. I can even copy and paste it. Copy crosshair widget. There it is. And the location, I do want it to be 0. I want to 0 it out. Compile it. And instead here of creating this crosshair reference UI, I'm gonna need a actor reference. Crosshair, just crosshair reference. Here I press actor, object reference, get, and if this is not valid, I need to create it. I'm not creating a widget, I'm creating an actor. So I need to spawn actor from class, find my widget. No, it's called crosshair, blueprint crosshair. Delete this. The spawn transform can be anything. It will be moved eventually by the trace. So I'm gonna split it. And this reference needs to be this one. I can also add the ability to hide and show it. I will not do this right now because I need to know if it's being created properly. And then here, I will not move this widget, I will delete this component. I will move this crosshair reference. And it's not gonna be set actor location, it's gonna be set, it's gonna be set actor location, not set word location. So now we are talking. So whenever I press play, and let me save, right click, we have the widget. It's colliding with the same widget, and we have it also there. And it's not showing as properly as I would like. But let's continue for now. I also need to give it a direction. So let's set actor rotation. And this new rotation should look to my character. So I'm gonna make it like this. Find look at rotation. This is a useful node. We just need two locations, a start and a target. My start will be this crosshair reference. Get actor location, and I want this actor to look at my target, that will be this character, self. And if I use the self, then it will look to my character, but it will not look at my camera. So what I need is the camera. World location. And this will be my target. Let's see if it's working. It's looking to the other side, then I just need
I was
here.
gonna tell you that you rotate 180 there.
There it is. Yeah.
This is way two-sided.
Yeah. So now uh, there is colliding with the floor, and here is colliding with that cube. That just as a quick fix, because it's driving me really insane. This spring arm, I'm gonna elevate it. I'm gonna press play. And now we have something more that can be shown.
Yeah, it's similar to Final Fantasy camera. A little far from the character, I guess.
Yeah, and we could
Yeah, it
also
is.
make it a little more dynamic. If this is 0, it shouldn't be 0. It should be a little bit. Oh, what have I done? Control C, don't crash, please. Yeah, it's like it was before. This is spring arm. We can move it during gameplay if we want to. In targeting mode, let's move it. And we don't want to move it in a world location because we really don't know where this spring arm is in the world. Like if I created my character, let me find it, BP Knight. Here the world location of this spring arm is totally different if my character is here. So I just need to move the relative location. And the relative location can be set like this. Set relative location. The current relative location is 8. So whenever I start this targeting mode, then I'm gonna put it like this. I want this location to be 90 watts to 100 watts to match, maybe 70. And whenever we end the targeting mode, and here I should hide the target, but I won't because I want to debug it first. This new location should be, it was 8, I believe. Let's put it 8. Probably should be in a variable, just so it's easier for a game designer to later polish this effect. And let's not leave any broken windows, so let's do that. And I'm gonna
Yeah,
split.
if you don't promote the variable, game designer will go crazy.
Yeah.
I never see them program to just change variables until they get it.
Normal camera height. And here, promote variable target camera height. So now we save it, compile, and whenever we target, our camera moves around. We later can add an animation there to make it feel really good. And I believe I broke something in my widget code. Or did I make this change? I did, right? Nope, I didn't.
Oh,
Save,
I
compile.
remember you did.
Yeah, I don't know what happened. Early access. There
Maybe
it
the
is.
control T. Anything happens, early access.
So now we need to determine which one is a good target, right? The floor shouldn't be a good target, but this box, maybe it can. The way we will do this is through components. We will create a component and then we will check if our heated target has a component. If it does, then it's an appropriate target, and if we see our graph, we're only on the second step, but uh, everything will flow.
We can split it into two live streams if it gets too long.
Yeah, so let's check that good target or bad target, right?
Mm.
I'm gonna create a component, content
To
browser.
see as far as we can go.
Yeah, you tell me. You tell me how much. Maybe uh, it's too long.
Yeah,
You just let me know and we can uh, end it
I will
right
let
there.
you know.
So let's create a folder for components. Oh, we should have like a target system, and we should have a folder named core. And inside the folder named core, there should be everything that is part of the core gameplay, like the targeting system. We could add also the UI here on the target system because it's related to it. Um, Maybe the widget, not so much, but I will leave it here. So now, here in my target system, right click it, blueprint class, I will search for actor component, and like it says, it's a reusable component that can be added to any actor. I created it, here it is. I'm gonna call it actor blueprint. It's sometimes called actor blueprint, actor component, actor blueprint component, but I'm just gonna call it blueprint. And then this will be um, target targetable component. And I really do not need to put any code here. The fact that this is present, it gives me the information I need. Later we can set up stuff for cooler animations here, but this is on the only thing that I need. Now I can go to the map. I want to target this cube. I will add here here we have details. Now we can add our targetable component. This component does not have something visually, but it doesn't matter. It only matters that it exists. So with that set in place, we can now check in my trace, and that rhymed for some weird reason. In the hit actor, we can ask components, get component by class. You probably don't need more than one targetable component, so get component by class should do the job. And here, I will search my targetable component. That was not it. This is it. And I want to know if it's valid. If the reference has been set up correctly, then it should be valid. And I will divide this. This is for rotation, location stuff. This is visual stuff. I'm gonna separate this by a sequence. And this other pin is for gameplay stuff. Here I check if the actor that I have hit has a component called targetable component, something from this class. If it's valid, then I need to play the animation, right? For now, I'll just print a string, hello, play, and if I target, oh, nothing is happening. Great. Oh, I'm hitting the widget. Yeah, I know what's happening now. This crosshair has a collision. This shouldn't have a collision because it's interfering with my trace. So here I'm gonna go to collisions, and instead of UI, I'm gonna put it as no collision. Now it should work as it. I put in the I target the floor, then nothing happens. I target my actor that has the component that I created, and it becomes targetable. Oh, there are a lot of access none. This is happening because we are trying to get something that doesn't exist, like the impact location. So to fix those errors that can drive you crazy really fast, we just need to ask is if it hit something. Just this return value should be fine. True if there was a hit, false if otherwise. Let's add it here. Now we shouldn't get any type of warning. Using a component instead of another blueprint actor give us a real advantage because this whatever we target could be anything. We don't need to worry about too much the.
That's really cool.
Yeah, it could be a
You
cone.
can actually put that component in a blueprint, like in a character you create. And even if you put it on a static mesh in the world where you can just decide, okay, I want to target this, and you don't have a blueprint for it, you just add the component in the level, and it will just work fine.
Exactly. So this works for this static mesh. I didn't add the component here, so there is no string. I need to work with all the knights. I could add it here, but if I wanted to work with all, I could add it in the component of the blueprint itself, and then all the knights that has this component. Then whenever we play, it will work, right? So that's awesome stuff.
Yeah. Very cool.
So now we wanted to play the animation. This animation. Here in my widget blueprint graph, we just need something to execute this code that now is forward. Let's do a custom event that will be called target found. And whenever the target is lost, then custom event target lost. I want this playback speed a little bit faster, a lot faster. So I'm gonna set it as, let me save compile 5, just to be really quick. Let me check if this is gray. Yeah, I believe it is. A little more. And in target loss, I want the opposite. The animation is still focus crosshair. I want it reverse. And I want this playback speed. Now, in my blueprint character, here I want to tell the widget component, the crosshair reference, that I found the target. So using this reference, this is an actor object, so I do not know anything that is inside it apart from things from the actor. We need to cast it to the blueprint crosshair. Let's cast it. Now, we could access the blueprint crosshair, get the widget, get widget, then cast this to my widget crosshair, and then use the how did I call it? Target found and target lost. Target found and target lost. But it's really not a good idea to run some code inside the components of another blueprint. The same blueprint should be in charge of running all its code. So this part, I just need to create a target found and a target lost here in my blueprint crosshair, event graph, custom event, and I can copy and paste the custom events with this. Target found. And now I can use its own components, widget, cast it to, oh, this widget component contains the class. So I just need to get widget. Where is it? Get widget. Target is widget component. This is the widget object reference that should be my crosshair. Cast to widget blueprint crosshair, and then call the same function. This is what in programming it's called a wrapper, because it is wrapping some functionality that already exists, and my knight does not know about the components of this. We don't need to do a lot of casts. We only need to do one now. Target found. And if it's not valid, then do the same thing, but target lost. And let's go to, let's save, compile, blueprint crosshair. We have added target found. We need the target lost. We use the same stuff. Target lost. Let's save it. Control Shift S to save everything. We can even save the map. Let me create a folder called maps. Demo map. Let's call it M demo map. Play. And now nothing happened. Great, just what I wanted to see. We can debug some of the, oh, here is a warning. Compile, save. Okay, weird. Blueprint crosshair, let me check is if this is being called correctly. It founds. I could press step into. It works. Step over. Playback speed is 5. In animation is correct. I can put my mouse on top to see the value of this reference. Start time 0, number of loops. Yeah, seems to be quite right. Maybe it was just
early access.
Yeah, maybe it was because it didn't compile well. So let's play it again. And
Okay. It just
yeah,
made us just got bigger.
yeah, it's changing.
It is. It is changing.
So we'll leave it at that for now. We can always polish it later. We just want to get it working. Now we have the target. In order for the target to not clip like this, like it's clipping right now, this blueprint where we have our crosshair, this widget, we don't need the default scene root. We can use the one in the widget. So let's make it the parent. And instead of a space word, we will put screen. We will not see anything here because it will render on the relation of the screen. So now
Oh, great.
it's better. And it's looking a lot
Cool.
more like we wanted it to look. Maybe I want
Yeah.
I want it for it to follow me whenever I'm not targeting something. I would just need to do something here when the hit is not done. So yeah, let's not worry about it now. Let's get to the fun part. After all that setup, we changed the crosshair. Let me check it. We start the
Like the
target.
mid UI.
What?
It's like the moving the character is the fun part.
Yeah, but
But I mean, it's we're putting the crosshair there. It already gave us like the location and everything, so not really for nothing.
yeah, and we're progressing. We started the targeting. We know if the target is acceptable. We change the crosshair. We need to do the input for the warp, for the warp strike, and then we do the warp strike, and then it ends. For the warp strike, maybe we can get to teleporting, and then we can worry about all the details later.
Yep.
So I need an input for the warp strike, because now that we have like the target, like we know this target is valid, or this target is valid, then we just need to wait for an input that maybe I will use the left click that right now we are attacking, but we could use this as a good starting point, right? So instead of attacking like this, I'll just cut it and put it a little more here. Let's see if something is really ugly. Right now it's really not that bad. You can also, you see this wire is crossing weirdly, and you could lost it if something increases. So you can double click a wire to have it create a reroute now node, and then we can have it like this. You could also select more than one node, right click it, alignment, straighten connection, or just press Q. There it is, Q. You want this to align also, right click it, alignment, align to the left, or you could press Shift D or A. You want it to distribute uniformly, alignment, distribute, or horizontally. This works better when it's only one line.
Also with Q, right?
That distribution, I believe there isn't a hotkey. But now it's looking a lot better. You could get very picky with how you want your blueprints to align. And when you have these types of connection, it will take in consideration the both connections. So maybe you do not want that. I certainly don't. So now let's go to the action. We need to know if we are targeting something targetable. We have this information here. And we also need to save the variable. Well, to save to a variable the object we're targeting, that is this one. So let's create a variable for this heated actor. Promote to variable and actor being target. This only needs to be set whenever we're targeting when the target is found, like this. This is where the wires really do not help us. Yeah, that's a little bit better. A little bit better. And we need to remove this saved value whenever the target is lost. To do that, just set the value to none. Doing this, remove the information that we stored in the variable. So now, when we attack, we can ask, is the actor being target valid? You can use the macro also. I'll use a macro because I don't need the other one right now. And if it's valid, then I should teleport to that location. Teleportation is really easy. You could right click, teleport.
I thought you were gonna use that print screen and put this is where my teleport will be if I knew how to write it.
Now let's do it.
Let's be confident.
Yeah. Let's trust in ourselves.
Yeah.
We don't need a location. Now this is where things get tricky. I could use this actor location, but I will teleport inside the actor. Let's see what happens. Hopefully I don't crash also.
Take everything.
Location.
Raise yourself.
Compile, save it. Ctrl Shift S to save everything. Play it. And I know the actor is set. Right click it and we teleport.
Better than expected.
Yeah. This is working because this cube does not have like it's not too big. If I increase the size, then Unreal won't know where to put me.
Right.
And also we have the problem that we'll always teleport to the same side, because the same algorithm of checking where to teleport. Yeah, it's checking the same way where to teleport me always, and it's not really good. So what I will need to do is do another trace, but this time I will do a trace with a capsule, because it's not a simple line, it's a capsule. Let's do that really quick. Capsule. And we can do a capsule trace by channel also. Visibility is good. Start. Well, my actor locations should be the end. My start should be the actual location of my night. So let's get actor location. If we don't fill this value, then it will use self, that is the same blueprint we're in. So we're doing it like this. And I put for duration, we need to set up the radius. We can get the radius from this component. Get radius. We want the scaled radius in case our component gets scaled up or down. And we need the half height. Get half height. Get scaled capsule half height. Perfect. Now let's play it. Targeting this, right click, and I can see where my capsule collides.
Awesome.
And that's exactly where I want to teleport. So let's use that information. Break. Blocking hit. I need the difference between, now I can explain it easily. The difference between impact point and location is that the impact point is the point where it collided. So here.
Okay. Yeah, that makes sense with the capsule. I can say it.
Yeah. This is the point where it collided. But the location will be the capsule location where it doesn't overlap the other mesh or component that it collided with. So this is the impact location, and this will be the location where I could teleport without any trouble of overlapping.
I see.
So let's use the location. Play, teleport, and there we have it. We're teleporting to wherever we want. Now we need to fix the rotation. We want to look forward to where we're looking, right?
Yep.
This rotation should be the forward direction from start. So I could get rotation. Fine, look at rotation, the start, the trace start, and trace end target. Play. And now, wherever I teleport will be a valid location. And I will look forward. There is a little problem because we are using all the rotation. So if I'm looking up, then my character will be with this weird rotation. So we really do not need everything here. So that's why in this code, they clean it like this. So I'm gonna do exactly the same thing. I just need a jaw. Split, destination, rotation. I only need the jaw. Play. And now it should work without messing up with the rotation of my character. So that's great for now.
Very cool.
I should not have to do this if I don't collide with anything. Because if I'm targeting something, then there should be a collision. So I'm gonna do exactly the same thing. If there is a collision, then we do the teleport. We just need to attack now. And for the attack, we already had as we explained at the beginning, which was like 2 hours and a half ago, that there was an attack input that plays the animation, we can do exactly the same thing. I can copy it, and after I teleport, and the order of the nodes is really important. First, I'm checking if there is an actor being targeted. Then I'm checking if a capsule has a collision. If it has, then I teleport it. And if I teleport it, I want to do an attack. And here's an interesting return pin. This is true if the actor has successfully moved, and false if it couldn't fit. So I'm gonna use that to know if the teleportation was correct. If it's true, it did teleport, then I should attack. And let me remove this draw debug. None. Play. I've selected this character, and now it attacks. Maybe it's too close, so I could fix it by increasing this capsule radius. I want this base capsule radius plus another variable called distance.
Maybe landing offset
There it
collision,
is.
something like that.
Oh, teleport landing offset.
Yeah.
So let's make it a little bit prettier by connecting it like this. This offset can be whatever we want it to be. 0 will not do anything, so maybe 100. Let's save and compile, play. Maybe 100 is too much.
Yep. Maybe 20.
No, wait. I broke something, I believe. Draw for duration, play. Did I broke something? Yeah. I broke it because I increased it maybe too much, and now it's colliding with the floor. It shouldn't collide with the floor. So maybe instead of a capsule trace by channel, I could do a capsule trace by objects. And here I can have object types that I could set up in order to only collide with the stuff I need. So this would require a little more setup. I won't use it. I'm just gonna reduce the 100 is too much. Maybe 20. It needs to be a little more. 40. Hmm. 60. Running out of numbers. Now it's colliding with the floor, so we can reduce the half height. And here where tweaking really becomes an issue. 20. But
you didn't connect.
I didn't connect it. But there will be a point where the radius is too high, so it doesn't matter if I reduce it or not. So let me do 50. And also I could tweak. I don't need to be too bothered with this. I could also tweak it at the end. That it will probably be better. Here, the location. I would just need to subtract. I have the lookout rotation, so I can get. Let me do it again. Like this. Recombine. Start. I could get the forward vector, and I just subtract it by the amount I need. That need to multiply this vector by this offset, and let me know if it got really confusing right now.
I think it makes sense.
Now, yeah, now it's being teleported a little bit behind. Let's do it again. There it is.
Oh, much better.
Maybe it's too much. Yeah, that's perfect. So we just got the final location, and we subtract an amount depending on where we are looking from, right?
Mm-hmm. Yeah, I was about to suggest this, but in my mind I was like, no, maybe too complicated. But that was just me.
Yeah.
It's like adding the offset after it's being calculated, the trace. Strangely enough, I'm understanding. Maybe my blueprint training, it's making effect.
Yeah. Being exposed to
And actually, I'm
blueprints
learning a lot on this one.
helps a lot. So now it's pretty much done, like the base functionality. It won't matter,
Yeah,
like, for example, if this cube was on top and we have another cube here, shapes cube, we can make it bigger. We can put this cube on top, and because the way of we are doing those traces, I would need to put it like more on top, because otherwise the capsule trace will collide with this cube, which
we
can
will
be,
just need to change the type of trace we're doing to ignore other kinds of objects, right?
yeah.
And right now it's colliding with that one.
Yeah, if depending on the angle, it will not teleport me to the top. So that's what happened there. But if I was far enough, didn't collide with anything, I'm teleported there. So looking now at our flowchart, we have checked that we are pressing the input, we are doing the warp strike, and on all the substeps of the all the substeps of the warp strike. Here, we haven't done this, we haven't done that, camera also, but the character does teleport.
It works. I mean, this is what we call the intention. So basically, technically, it works. Then you will be going to the second part, which is like the realization, where we will be showing off exactly how we want the feeling for the player to feel when we click on this. So that goes like the camera, offset, the particle system, the sound, all of those little details had a huge uh, impact on this one. But I think that main logic is there.
Yeah, we only need to polish it. Like maybe we could replace this capsule by a sphere trace and then connect everything behind it, just to avoid that silly error of colliding with a terrain. Or we could also create our own channel. That
Mhm.
actually that could work a lot better. And it's really not that complicated to do. You just need to know a little bit about collisions that maybe we can go over next time. But quick example how to do it. Project settings. We have here in engine collision, and here trace channel. We just need to add a new one called blink, because it will be our blink channel. We want by default for everything to ignore it, accept, and now we tell this this cube in the collisions. Where is the collisions? Here, default, custom, and this blink channel we tell it to block it. In order for not to rely too much on custom collision presets, we can create our own presets for the for everything that will collide with this. And in this way, now in my blueprint night, here instead of visibility, let me save and compile. I will have blink and then play, and then I can do it like this. And that teleport didn't, but it didn't collide it. Where's the teleport? I'm using that offset. Let me change it to 0, and it's gonna be a thing about tweaking in those edge scenarios, because the life of the programmer is really not perfect. There are a lot of stuff that can happen, like, oh, I want to teleport right there. You should do it, but now we can't use this logic of teleport landing offset. So you need to find another way of doing exactly this, but not like this, because it's not working.
Yeah, but it's not also the. I mean, of course, the programmer will find the solution, but there are also a lot of cases where they just create rules. Like if you want to put a teleport here in this map, like your mesh should be like this, and the collision should be like this, and it happens a lot on the games where they have a lot of rules for the collisions, which type of collision, what is the angle of the objects in order to work uh, the best in most scenarios.
Right. Yeah. Design decisions help a lot, help save a lot of work that you're trying to make it work in a case that will never happen. Yeah. It's really pain in the ass to do that. Find a solution and then they tell you, no, it's not gonna be used that way.
Yeah, but cool. I like it.
Yeah, that would be.
Maybe we can use another stream to do some tweaks to really show the if there like we said at the start of the stream, there is a lot of things going on here, like 3Cs, character camera controller is not something you do so fast. It involves like the character, involves the animation, the camera, the input, And on top of that, you also have the effects and the camera. But I think it will be very fun to do them, like playing with the effects. And once that the main logic is there, if we have like a nice setup where we could play with the effects, I think we could have really fun results if we show it next time.
Yeah. Uh,
Okay, so
that
for
would
me,
be
that's
it.
it. I'm not
Yeah.
sure if you want to add anything else.
No, I believe anything more would be an overload of information. So we can
Okay,
leave it like here, like right there, and then polish it later.
sure. All right, then until next time.
Have a good one, guys.